Today's episode of Spike's Science Spot was inspired by a video that my colleague, Bruja of Bruja's Magical Storytime, shared with me. So hold your horses, fellow scientists. This week's topic is physics. A paper horse that walks. Yes. Shout out to Frugal Fun for Boys and Girls website for the instructions. Of course, I had to make a couple of paper horses, and here's the result. If you've watched the first 2 episodes of Spike's Science Spot, you know I'm all about the observations. So, after watching the paper horse races carefully, I've come to the conclusion that friction is a key component to why the paper horses can race down the ramp successfully. What is friction? The definition of friction is the resistance that a surface encounters when moving across another surface. For example, when you're trying to push a box, it's the force that resists your pushing. A lot of our day-to-day living is about balancing friction. If there wasn't any friction at all, we wouldn't be able to walk. It'd be like spinning our wheels. If there was too much friction, then our feet would be glued in place. In a piston engine, if there's too much friction, heat builds up and the parts wear out super quickly. That's why we use engine oil to reduce friction. There are advantages to friction. For example, we couldn't walk without friction. Tires wouldn't grip the road and our cars would slide everywhere. Nails need friction to stay in place, and that holds our houses together. And without friction, we could not hold on to objects. Friction comes with disadvantages. Our shoes wear out. Machines wear out over time. When surfaces rub against each other, energy is lost to heat. Friction slows down cars, so they are designed to minimize any frictional losses. For this next demonstration, I'm using an organic chemistry textbook from my college days back in the Cretaceous. This textbook weighs approximately 1.8 kilograms or 4 pounds. That's about a half gallon of milk. So let's think about static friction. Have you ever noticed when you start pushing something, but then you need to push a little harder before it starts moving? Well, that part in the beginning you have to push to overcome static friction, and then when it moves, that's called sliding friction. Now, if we want to make it even easier to move an object, we can take advantage of rolling friction. To make this textbook roll, we need to make a rolly surface. So we would need either cylinders or spheres. And for spheres, I chose these marbles in a plastic lid. So we'll put that under the textbook to have a rolly surface. And now I can spin the book with very little effort. Let's make some observations about fluid friction. When we say fluid, we mean a substance that is either liquid or gas. Let's look at ice. It's a solid and not too slippery. But As it starts to melt, we get a layer of liquid water, a fluid, on the ice, and it becomes very slippery. Ask permission for a pan, ice, and some water. Experiment and observe that a fluid layer reduces friction. This is the same phenomenon that makes an air hockey game so fun. You can use ice cubes, chips of ice, or even a big block of ice. So go ahead, experiment, enjoy, observe, and get back to me about what you learn about friction.